So, good day everyone. For today's topic, we have the area and volume. But first, we will discuss the area. So, in area, there is a three methods that we're gonna find: the under the curve, between the curve, and the polar areas. And each one of here, we will give an example so you can understand it more and clearly. So first, we have the first example. Find the area under the curve y is equals to square root of x from x is equals to 0 to x is equals to 4. And the solution for this is the example of the graph. This is the point of origin, which is the 0. So, mark the line here. So this is 1, 2, 3, 4, and in the x-axis 1, 2, 3, 4. It's the 4. And now we will find the limits. Now we're gonna draw the x and y. X here and y. R is 0, 1, then 4. And 2. So now we can plot our line, which is here 2 to 4. We're just gonna draw the broken line. And here, now we're gonna draw our line. And the vertical strip is in here. And this is the area. And draw here the x. This is the x. And the vertical strip is called the dx. And here is the y. So now we're gonna solve it, the dA, and the equation for this y dx. Area is equals to the limits which is 4 and 0. Y dx equals 4, 0, and the x, the y which is x, square root of x dx, which we will transform into integral of upper limit 4 and lower limit 0, x raised to 1/2 dx equals, use the power formula, x 3 squared over 3 squared 0 equals 2/3 the y which is square root of x raised to 3 equals 2/3 times 8 minus 0, and 8 minus 0, which is 8, so 8 times 2 is gonna cross multiply it, so it will become 16 over 3 square units. And that's how you get your final answer for the example number 1. Now here is an example number 2. Find the area under the line y is equals to 5x plus 3 from x is equals to 0 to x equals to 5. Now we're gonna draw the graph. Oh, sorry, you can't see. Here is the point of origin, which is 0. One, two, three, 4, 5, 6, 7. One, two, three, 4, 5, 6, 7. Just like what we do here in the first example, we will use the x and y. Which is our x is equals to 0, y is 4, 3, and 1, 6. So here is the 3, which is 5, or so 5, 5, 6, 6. Oh no, sorry. Of ruler. Here is the strip. x y right here, dx is 3 4 dx y. Oh, I'm sorry, this is 3 and y is equals to 3x plus 3. I'm sorry, that's 3x plus 3. And our dA, which is y equals to dx. Our limits, which is upper limit 5 and lower limit 0, y dx is equals to 3x plus 3 dx. X squared over 2 plus 3x 0 equals 3 over 2, and then put the 5 squared plus 3 times 5 minus 3 squared 0 squared plus 3 times 0 equals 5 over 2 plus 15 squared units. And that's how you get your final answer. And now we're gonna do an example for the method number 2, which is between the curve. Find the area between the curve, and we will draw a graph. Point of origin is 0, and is this f graph. y2 is equals to x. y1 is equals to x squared. And here is the vertical strip between the curve. Sorry for the background noises. Which here is equals to dx. First, we're gonna find the intersection. Y is equals to y. X squared is equals to x. So x squared minus x is equals to 0. X times x minus 1 is equals to 0. So our x here is 0. X minus 1 is equals to 0. So x is equals to 1. The vertical strip dx. YL minus YB dx. Our limit here is 1 and 0. So x minus x squared dx equals x squared over 2 minus x cubed over 3. In here we just use the power formula, so equals to 1/2 minus 1/3 0. So the equation is 1/6 squared units. So that's how you get your area between the curve. So good day everyone, and for today's topic is volume using integration. And in volume there is a 3 method, which is the disk method, shell method, and the washer method. But first we're gonna do the disk method and give you the example. So what is a disk method? A disk method is the process of finding the volume of an object by dividing the object into many small cylinders or disks, and then adding the volumes of the small disk together. So here is the example of disk method. Determine the volume of the areas under the curve y is equals to e raised to x from x is equals to 0 till x is equals to 2, rotated about the x-axis. And for the graph, I will draw it. Here is the point of origin and up. And here is the block 2, rotated about the x-axis. And here is our and here is a vertical strip, and this is in the sample determined rotated about the x-axis. And we're gonna put here this is our disk here. This is the dx. Y is equals to e raised to x. Here is our x, and this is the dx. And here is the y and x and y. I'm gonna draw here the disk. R X. So to find V is equals to EX is equals to EX. X is equals to 0 and is equals to 1. dy is equals to, here is our formula, pi y squared dx. V is equals to, the upper limit is 2 and lower limit is 0, pi times ex raised to 2 dx is equals to pi integral 2 u du is equals to x is equals to 2 and u is equals to e squared equals to pi integral of e squared 1 u du equals pi times u squared over u 2 e squared 1 equals 4 2 minus 1 half is equals to pi e raised to 4 minus 1 over 2 cubic units, and that's how you get your answer using the disk method. Now we're gonna do the shell method. But first, what is shell method? So, shell method is a method of finding volumes by decomposing a solid of revolution into a cylindrical shells. And for example, we will draw a graph here. This is a big one. Y is equals to fx. Sorry, no parentheses. Sorry for the background noises. And here is our point A, and here is point B. This is our Y. And here in the below is the cylindrical sorry for not drawing it properly. Here is a dx, here is the x. And to solve for that is v over a 2 pi xy dx. And here is the formula to solve the shell method. Here is the horizontal strip to xy. Here is our y. So dv is equals to 2 pi y dx. Of a 2 pi xy dx. And this is the formula for the shell method. And now we're gonna do the washer method. So what is washer method? Washer method is the application of the method of slicing. The shape of the slice is a circle with a hole in it. So we subtract the area of the inner circle from the area of the outer circle. So for example, in the washer method, we're gonna do here the graph first. We're gonna do here our graph first. Zero, my origin. Y square root of x. So here is our vertical strip. And we're gonna do here which is a small circle or the inner circle, and we're gonna do here the outer circle. And here is equals to y1 r dx 1.1. We're gonna do here another dx. Here is y1 sub 1, y sub 2, ar. And to solve for this example, we have dv is equals to pi y dx minus pi y dx equals, our upper limit is 1, lower limit is 0, pi y sub 2 raised to 2 minus y sub 1 raised to 2 dx equals pi times x minus raised to 4 dx. Why it become raised to 4? Our x here is, our sub 1 here is the what? Here. So times 2 it become 4. And here, and if you put it in fraction, this is x 1/2 raised to 1/2. So if you times 2 it will become 1. So it's 1x minus x raised to 4 equals pi x squared over 2 minus, use your power formula here, x raised to 5 over 5 10 equals pi 1/2 minus 100 over 5 equals 3 over 10 pi cubic units. So that's how you get your final answer using the washer method. Thank you for listening. That's all.